I'm Effie Parks. Welcome to Once Upon a Gene, the podcast. This is a place I created for us to connect and share the stories of our not-so-typical lives. Raising kids who are born with rare genetic syndromes and other types of disabilities can feel pretty isolating. What I know for sure is that when we can hear the triumphs and challenges from others who get it, we can find a lot more laughter, a lot more hope, and feel a lot less alone. I believe there are some magical healing powers that can happen for all of us through sharing our stories, and I'll take all the help I can get.
Once Upon a Gene is proud to be part of Bloodstream Media. Living in a family affected by rare and chronic illness can be isolating, and sometimes the best medicine is connecting to the voices of people who share your experience. This is why Bloodstream Media produces podcasts, blogs, and other forms of content for patients, families, and clinicians impacted by rare and chronic diseases. Visit bloodstreammedia.com to learn more.
Hey friends, welcome back to the show. If you're new here, welcome. There are so many amazing episodes in our back catalog, so go check them out. Text me if you're looking for something specific, and I will send you a link. My name's Effie Parks, by the way, and I host this beautiful show, and I'm so grateful to be able to be here with you and have these conversations about rare disease advocacy. So if you haven't joined the Once Upon a Gene Therapy Walking Club yet, go check it out. What are you even doing? We're getting our steps in and we're finding strength in empowering each other, motivating each other, and just really encouraging each other to take a little extra care of ourselves as caregivers. So go check it out. They're all over my Instagram/Facebook, and the New Year's episode also delves into it. So go check it out. Okay, so today in this episode, we're talking about the groundbreaking initiative called BeginNGS, which is a consortium that stands at the forefront of genetic sequencing and rare disease diagnosis. So we're going to uncover its origin and the project itself, its critical phases, and the vital partnerships that makes it all possible. So joining us today are the esteemed guests, Dr. Stephen Kingsmore from Rady Children's, Tom DeFay from the partnerships team at Alexion, and the one and only Wendy Erler, also from Alexion. So together we're going to have a great chat. We're going to hear about their vision, the challenges, and the hopes tied to this pioneering program. So buckle up. Here we go. This is an insightful conversation, and I hope you enjoy it. Please enjoy my conversation with Dr. Stephen Kingsmore, Tom DeFay, and Wendy Erler. Hello, everyone. Welcome to the podcast. I'm going to start out with a couple little brief intros. I have Wendy Erler, I have Tom DeFay, and I have Dr. Stephen Kingsmore. So let's just start out with a little who are you and give us a little brief intro. I'll start with you, Dr. Kingsmore.
Hello, I'm Stephen Kingsmore. I'm the president and CEO of Rady Children's Institute for Genomic Medicine, which is a research institute located in San Diego, California.
How about you, Wendy?
Hi, Effie. My name is Wendy Erler, and I lead patient experience at a rare disease company called Alexion.
Tom, my new buddy.
Hi, I'm Tom DeFay. Great to meet you, Effie. Really happy to be here. I'm Deputy Head of Diagnostic Strategy and Development for Alexion, and I'm also Deputy Chair of the BeginNGS Consortium, which Stephen is the chair of.
Excellent. Okay, so I have three really amazing, smart people who are all working together on a really important project. So I'm excited to get this conversation going and share it with my rare disease audience here. Dr. Kingsmore, can you outline the idea that led to the creation of BeginNGS?
The idea that led to the creation of BeginNGS was, what if we could prevent or reduce the impact on children of rare genetic diseases? What if we, for maybe 1,000 genetic diseases, what if we could either completely prevent them or minimize the suffering, minimize the cost, minimize the delay? Rare genetic diseases, as probably all of your listeners know, are an immense health ecosystem challenge. And the challenge is a timely diagnosis. So on average, it takes 4.8 years to diagnose a child with a genetic disease. And during that period, children get worse and worse. Their symptoms get worse. Their disease progresses. They may die, in fact. And during that period, again, as your listeners well know, parents go from pillar to post, from specialist to specialist physician, test to test. Treatments are tried, usually symptomatic treatments, until finally, hopefully, a diagnosis is made, the right diagnosis, and appropriate therapy is started. That's what we want to eliminate. We want to eliminate the 4.8-year average delay in diagnosis and effective therapy for every preventable or treatable genetic and infectious disease in every child in the United States.
And Stephen and probably Tom, when did the idea to collaborate with Alexion and establish this consortium kind of begin? Is this the tinkering phase still? Like, how did that happen?
So we've been meeting with Stephen and the Rady Children's Institute of Genomic Medicines regularly in San Diego, about 4 times a year. And every time we'd go to those meetings, we'd have a plan for how we could transform diagnostics in children's lives. And no matter what we did, that plan would change after meeting and discussing for about a couple hours. And this was one of those cases where about a year and a half ago now, we came in with a plan about how to do rapid diagnostic screening. We said, let's see if we can do this for newborns. Let's see if we can take this to the next level. It was a great discussion.
Wendy, Alexion, I love Alexion. Their support for Beginnings is so awesome. It's so commendable. Can you explain why you found Beginnings to be such an important initiative to back?
Effie, I think we all share the same vision for all of us that are connected to the rare disease community, whether by choice or by chance. And really, ultimately, that vision is a world where every rare disease patient receives the right effective treatment at the right time. And for us at Alexion, this isn't just the diseases where we have research programs and even medicines, but all rare diseases. And that starts with changing this diagnostic odyssey and ensuring an early, accurate, fast diagnosis. And the work that Stephen's doing has the potential to really deliver on this ultimate mission and vision.
Yeah. Dr. Kingsmore, can you kind of go through it a little more in depth and highlight the phases, phase 1 and 2 of Beginnings?
So phase 1 was the first phase, obviously. We went from a concept, the concept I just described, to a working prototype. That took about 2 years. We finished that 18 months ago, phase 1. We published 2 manuscripts in the scientific literature describing the prototype and showing that it could work. The prototype was for about 390 rare childhood genetic diseases that have effective treatments or that can be prevented entirely by treatment. And a prototype means that it works. It works in a research environment, but it's not scalable. It's not ready for commercialization. It's not ready to be put into practice. It's an experiment. So that was phase 1, and that finished, as I say, 18 months ago. Phase 2 is the phase that's just about to finish. So it's now St. Valentine's Day 2024. And so over the last 18 months, we've completed phase 2. In phase 2, we re-examined every disease that we had looked at in phase 1. We had expert physicians and geneticists look over every single one. They threw away about 30 of the diseases that we didn't feel should be retained because they didn't quite meet the criteria. And then we added about 50 more diseases. And so our total at the end of phase 2 is 412 diseases and many more treatments. It's about 1,800 different treatments. In addition, in phase 2, again, we proved that it worked and we built the first diagnostic version. So the first clinical version of Beginnings, one that can be done in human subjects. And we actually did a pilot study in 120 critically ill babies in our intensive care unit to prove out that it would work in practice. That's phase 2. Phase 2 has been successful. We will be publishing the results of phase 2 at some point during the next year.
So it's currently and still only being done at Rady Children's. It's still kind of in that pilot phase.
So we are still in the pilot phase of Beginnings, and it is being done only in patients in San Diego County, largely through Rady Children's Hospital system.
I remember reading a paper, or maybe I even heard you at a conference talking about the financial differences in what you're doing and how much money it's saving the system and families. Can you talk a little bit about that?
When we think about how many dollars, healthcare dollars, we could save, it's really quite tricky to garner an estimate. But the closest I can come is about $1 trillion. That's the estimate. It's now about 5 years old. It's a 5-year-old estimate of how much healthcare expenditure goes into rare genetic diseases each year. We anticipate that more than 1,000 genetic diseases will be impacted, and so the potential savings could be as much as $1 trillion per year. Of course, we need to do studies to actually prove that out. That's a best guess at present.
Yeah. Wendy, as you know, we always hear kind of a world where every rare disease patient receives the right effective treatment at the right time. Can you delve into that a little deeper for us and into the vision and the implications of it for our patient communities that you're so close to?
Wow, Effie, that's a huge, huge question. But to bring it down a little bit, to add on to what Dr. Kingsmore was saying, the other thing to think about, whole genome sequencing can make it possible to also have test results in just a few days. And when you think about that whole concept of knowing that there's something not quite right and wanting to get that answer, this all accelerates the process of getting to that answer. And the more rare diseases that have a name, have a diagnosis, the more advanced research can be and the more quickly treatments can be discovered and developed. But it's very complex and not a great system today. So we have a lot of work to do. I think the other thing, we're starting to hear a lot more about is there's a lot more about these conditions that is the same than is different. So where there are advances in one group of conditions like neuromuscular genetic diseases, where potentially you can accelerate a therapy for one condition because you know a lot about an adjacent condition. So a lot to come, but I do think everyone that's focused on early diagnosis, the reason for that is to make sure that these rare diseases are counted, have a name, and then their path to what do we need to do to treat it is a little bit more clear.
Tom, wondering if you can elaborate more on the consortium mission itself and what your eyes are on the future for it.
So this consortium, the Beginnings Consortium, we already have, I think it's 24 different partners, 14 different pharmaceutical companies and biotechs have joined, sharing that vision of the right effective treatment at the right time. And our vision is exactly what Stephen articulated. Ultimately is to make sure that every baby born in the United States has the opportunity to be screened in this way for these devastating disorders. And I wanted to add to the discussion around the 409 diseases. This effort is so important. We really want to make sure that we move forward in sort of the most in a cautious way, but in a very effective way. So we want to focus on the diseases where the need is the greatest and make sure we can really roll this out in the right way. And that's why we're doing it in a step-by-step way. I agree with Stephen. I think we're going to expand to 600 or 700 disorders over time, but really getting it right for these 409 diseases would be an enormous step forward.
And Effie, if I can add, one of the things that I think really differentiates this work and the consortium in particular is the patient communities have been represented at the table from the beginning. And I can assure you that this was really important to Rady and to the other pharma companies that joined the consortia. And we're super proud of this because we know that none of these pieces of work and solutions can be developed in isolation. And the patient community contribution has been from every step of the process, consent and questions around how you share information and ethics. It's been really impressive to have all of those voices at the table.
That's a really great point. So we've started a number of working groups to help advise and drive some key questions. And some of those working groups are being led by members of the patient community. And to me, this is critically important to make sure that what we deliver is valuable for the patients.
Thanks for adding that. I was going to ask for an example, so you swooped right in there, Tom. Dr. Kingsmore, I would like to go back on something you just barely mentioned about pediatricians. They're our front line as families bringing our kids in, especially if they slipped that opportunity, if you will, to be in the NICU at birth and were sent home. How do we sort of educate our pediatricians on calling for these genetic tests sooner than later, or even being able to call them themselves and order these tests? I know too, like the cost involved is so, you said negative a moment ago in the scheme of things, but even now, families I know every single day are being told that it's too expensive and insurance won't reimburse it. What are your thoughts on all of that?
It's a great question. How do we educate our pediatricians to order genetic testing sooner? We have struggled a lot with this. By and large, the problem with rare genetic diseases and rare infectious diseases is they're not top of mind for physicians. Physicians are rigorously trained to think first of common diseases. And in fact, during our training, we are criticized if we think about rare diseases. We're taught rigorously to think common diseases. And so part of the problem that we face in the rare disease community is retraining pediatricians and other physicians and healthcare providers to think in a new, different way. We're not saying that they should ignore common diseases, but they should retain a high index of suspicion for rare genetic diseases in certain situations. One is in the most severe diseases. So, for example, any disease that leads to a child being admitted to an intensive care unit, any disease that occurs more severely than is generally seen. So, for example, very severe seizures, but really any very severe disease or any disease that's not responding to typical treatments. So, for example, we have first-line therapies for most common diseases. And if the child isn't, let's say the child has an infectious disease, has sepsis, and is not responding to antibiotics, all of these things should prompt a pediatrician to think about genetic testing and to order that immediately. So we have been working hard with various health systems and with policymakers to actually develop policies around when genetic testing should be ordered, and in particular for genetic testing in hospitalized children. And I'm really glad to tell you that that is starting to gain traction, that in fact 10 different US states now have policies for Medicaid coverage of genetic testing by rapid whole genome sequencing. And that's so significant because genome sequencing has the potential to diagnose almost every genetic disease that's known. So one test for almost every genetic disease diagnosis. And the fact that that would be covered by national health insurance, by Medicaid for children is huge, because over 1/2 of the US population have their hospital bills paid by Medicaid. In addition, Blue Cross Blue Shield, one of the major payors, private payors, has a policy to cover the same testing, rapid diagnostic whole genome sequencing, for the same population, so for hospitalized children nationwide. They're the first major payor to do so. We hope that over the next 12 to 18 months, that every other state will follow suit with the first 10, and every other major insurance company will follow suit with Blue Cross Blue Shield and allow this to reach every child in need across the US. That won't be the end of the problem, though, because as you asked me, we still need to educate the pediatricians to order the test early during a disease as opposed to late in the disease.
Oof. If you had two major pain points that are kind of a barrier for you leveraging this idea, what would they be?
So two major pain points in terms of newborn screening for all preventable genetic disorders and for broad use of rapid diagnostic genome sequencing are, number one, what I just spoke about, the fact that pediatricians tend to order genome sequencing rarely. So we estimate that only 2% of the children who need this test get tested. Can you imagine? Only 2%. We estimate the need to be 200,000 families a year, and that only probably 4,000 tests are currently being ordered per year. So that's a major pain point. And the second one is that even when testing is ordered, it does not always translate into the optimal therapies for those children. And there still can be delays in giving them life-saving treatments. And that's especially painful as we have new treatments, such as gene therapies, that can actually cure a genetic disease. And so the idea that testing can be done, we can rush the results back to a physician, and then there are still delays to get life-saving treatments in place, is also a major pain point.
Ooh, I think every parent is nodding along to that one. I think we'll personally celebrate a day where panels are not the go-to, like at all. It wastes a lot of time, and as your financial report, it wastes a lot of money, but it's our kids' lives, and time is brain, as a lot of them would say. Tom, I think there's some seats at the table in the consortium for some pediatricians.
Yep, absolutely.
Yep. Go ahead and put that on your list. Can you explain exactly what whole genome sequencing is?
Sure. So, you probably have been hearing about whole exome sequencing, where you're sequencing portions of the genome. Whole genome sequencing is exactly as it sounds. It's sequencing the whole thing. Now, when we sequence the whole genome, we're only examining, like we said, those 409 diseases that have treatments available. But as we go through this work, we can add additional diseases simply by looking at that portion of the genome and going after it. And also the technology around whole genome sequencing allows us to run some additional tests that are difficult to run in the whole exome way. So it's a more sensitive test, it's a more complete test, and it allows us to scale more rapidly as we add additional disorders that have treatments available.
Thanks, Tom. Stephen, are you analyzing all the data and doing those reports like at your facility, or are you handing them off to a third party? And if you aren't, would it be more efficient to do so you can concentrate on what y'all are doing, or are you keeping it in-house for a reason?
Yes, we are analyzing genetic test results at our lab, at our institute, at Rady Children's Institute for Genomic Medicine. And in fact, we had a milestone last week. And that was that we added our 100th hospital. It's Trinity Hospital. It's a children's hospital, and it's the 100th children's hospital to join our network and to order rapid diagnostic genome sequencing through our lab. So we now have 100 different partner hospitals from all over the United States and also from Canada. And this year we will test roughly 1,200 families. So that's mums, dads, and babies or older children. We are very excited because that will be about a 30 or 40% increase over last year. And in fact, our run rate so far in 2024 is higher than we expected. And I hope we may actually get up to 1,500 families who get an answer this year. So for the second part of your question, we're still working really hard to make this more efficient. And by more efficient, I mean that we want to increase the rate of diagnosis. So about 1 in 3 families will receive a diagnosis. Some of those diagnoses are something that your listeners will have heard about. It's so-called variants of uncertain significance. These are variants that we don't really know whether they're causing disease or not. We're keen to eradicate those. We're keen to have unambiguous results so that yes, your child has a genetic disease, or no, they do not have a genetic disease. We're still working on that. That's something that we need to become much more efficient at. We also want to increase the rate. Recently, we switched on testing for what we call repeat expansion disorders. One of those is myotonic dystrophy. And in the first 3 or 4 months of adding that new test to our menu for rapid diagnostic whole genome sequencing, we had 1 new diagnosis every month. So there are still significant gains to be had in terms of the proportion of children who will get positive results. And that means that even in families who've had a negative result, it makes sense to retest them, to reanalyze that data after a period of time. We're keeping this in-house currently for a couple of really important reasons. First of all, we are a not-for-profit research institute, and so we are motivated not for profit, but out of a mission to alleviate human suffering as part of a hospital system. And that gives us a different lens to look at this through, and it means that we can do testing in certain circumstances for free for families who can't afford this, because we don't have to make a profit. In addition, it allows us to do a lot of research, just as I described with Beginnings, to make what we do more efficient, faster, and better. And there continues to be a need for that, even if that's not commercially viable. But we are considering how we close the gap, right? I told you earlier that only 2% of children who need this are getting this test this year. We need to close that gap. We have 98% gap to fill. And so we are considering strategically what are our options to go from 2% to 100% of that need being met.
Are there any findings from phase 2 that you're allowed to share publicly or that you're excited to share publicly?
Yes, so there certainly are. One of the most exciting findings is that this test really works. And I'll give you an example of that. So we've been doing rapid diagnostic genome sequencing now for almost 9 years at our institute. And one case that I remember really well, we published in the New England Journal of Medicine and actually set a world record for fastest diagnosis, was a little boy who was seizing in our intensive care unit. And we found that he had a very rare genetic disease called biotin thiamine responsive basal ganglia disease that was causing his seizures. And we were able to make that diagnosis in 13 and a half hours, which allowed us to start treatment before he incurred brain damage. And he went home and he should do really well. However, his sister had died 10 years earlier of the same symptoms. So severe seizures that were unremitting, and she died at less than 1 year of age. So as part of our phase 2 Beginnings study, we looked at 1,000 babies who had died over the last almost 15 years in San Diego County. And one of those babies was a little girl who had exactly the same disease, so biotin thiamine responsive basal ganglia disease, what a mouthful, with the same variant, the same causal mutation. That is almost certainly that little boy's sister. So we were able to identify that. Now, tragically, she had died, but what that tells us is that our new test would have saved her life had it been available. So she's one of many, many cases that we studied in phase 2, because we restudied about 7,500 genomes that we had already done diagnostic genome sequencing in, as well as 1,000 babies who had died of unknown causes as part of this study. And we found, in fact, a couple of hundred babies who would have benefited. So that's very exciting. We've proven out that this test, Beginnings, will work well when we are able to test every newborn for 1,000 treatable and preventable genetic diseases.
And if I could add to that a little bit, this newborn screening test is a screen. There's newborn screening by whole genome sequencing. It's a screen. And it's really important for the doctors also to have information around what is the next step in the process to confirm the diagnosis and to make that information available as well. Because ultimately, the physician involved needs to be making the diagnosis after we do the screen.
Okay, so let's talk about hopes for the future. Tom, Stephen, what are your aspirations and the trajectory for Beginnings?
Well, we now lead a consortium of about 30 different organizations, and that they include rare disease advocacy organizations. They are parental support groups for rare genetic diseases. They are healthcare systems, policymakers, experts in academic medicine, biotechnology companies who are inventing new genome sequencing methods, new informatic and artificial intelligence methods, and pharmaceutical companies who are developing new treatments for rare genetic diseases. So that's our consortium. It's the Beginnings Consortium. And our hope is that we will increase the size of that consortium to over 50 different organizations. If you're listening and you'd like to get involved, please reach out to Effie and she'll put you in contact with us, because we want to grow this. It's an open organization and we need every voice. We need every race, every ethnicity, every ancestral group, every geographic region. We need every socioeconomic status, and we need every genetic disease to be represented in our consortium. We need to raise the finances to be able to do our pivotal clinical trial. We estimate that we will need to test over 15,000 babies. So another strong aspiration is to raise grant support and funding from our consortium to be able to complete this and to be able to actually commercialize, to productize Beginnings as a test and to deploy it. And our strong goal is to deploy it for the first time in a US state or in a large healthcare system and reach the majority of the babies served in that region, in that state, or in that system, and to do that within the next 5 years. So that's by 2029. That's our single biggest hope and aspiration for the future for Beginnings.
Amen. I mean, seriously.
Effie, every time I hear Dr. Kingsmore talk about this potential, I think about Ryan Sheedy's story and the binder, and how so much of the responsibility on rare disease families moves immediately from the physician to the parent, and the parents have to become disease experts and management experts and seek out alternative therapies for care. And if we could solve for that alone in the way Dr. Kingsmore describes, it just would be a huge step forward.
Thanks, Wendy. Yeah, I do understand grown-up land in all of this. However, I am in team like a patient advocacy org who's contributing to research is a form of a treatment. May it not be medical, of course. And then also I think about those babies that got sent home, like my son who shouldn't have been sent home. And so in the perfect world, this is also the curtails that gets to jump on this as soon as it's finally widely accepted and is the norm, like Dr. Kingsmore mentioned.
And we have a sense of urgency. We don't want to have this happen in 30 years. The technology exists now. We can make this happen now. And so we're working very hard to try to make this a reality as soon as we can. For every child in the United States, could happen as early as 2030. That's a stretch. It's an audacious stretch, but it's something we'd like to become a reality.
Yes. Wendy, in your Wendy way, do you have anything warm and fuzzy to leave for our patient community? Any opportunities you'd like to leave them with, or just some hope?
You asked the question about what is the dream, and I think the dream really is to end the diagnostic odyssey for all of these rare disease families. And we hear the same traumatic story over and over and over about the seeking information process. And if we can make that better and provide a community for families where they actually have an immediate place for connection and information, and then get to the world where there is a treatment, to me, that's the dream.
Thank you three so much for all of your work, and I champion you. And I know that this will get into the ears of everyone who actually does see a pediatrician and who even is a pediatrician. And I think just the more people that are aware that this is real, this isn't science fiction, that it will just get louder and there will be more advocacy surrounding it from conversations like this. So thank you all so much for taking the time to talk with me a little bit about it. And I'm just so thankful for the work that you're doing.
Effie, thank you.
Dr. Kingsmore and the team at Rady Genomics are inviting Once Upon a Gene listeners to their annual Frontiers in Pediatric Genomic Medicine Conference, May 1st and 2nd in La Jolla, California. This seaside conference features research presentations about the ways genomics is reaching beyond the NICU and informing care in behavioral health and neuro-oncology. The conference also includes a family panel where parents will share their firsthand experience with whole genome sequencing and genomically informed care. If you can't join in person, there's also a virtual option. So for more information on the conference and to register, go to radygenomics.org/frontiers, and I'll also have it linked in the show notes.
I hope you've been enjoying this podcast. If you like what you hear, please share this show with your people, and please make sure to rate and review it on iTunes or wherever you get your podcasts. You can also head over to Instagram, Facebook, and Twitter to connect with me and stay updated on the show. If you're interested in sharing your story, or if you have anything you would like to contribute, please submit it to my website at effieparks.com. Thank you so much for listening to the show and for supporting me along the way. I appreciate y'all so much. I don't know what kind of day you're having, but if you need a little pick-me-up, Ford's got you.